So this is going to be a lesson on finding the equations for trig graphs. Now this is a fairly important one in terms of exam questions and also in terms of understanding cosine, sine, and tan graphs. So I'm going to go work through a few examples. First off, strictly sort of equation-based ones, and then moving on to graphs themselves. So to begin with, if the graph of y equal cosine bx has the following periods, find the value of b. So the b is the factor that controls the change in period, or horizontal stretch factor, if you like. So we know that. But unlike the previous batch of questions, we are not attempting to find the period, or we will not be attempting to find the period. Rather, we will be trying to find the b value when you're given the period. So it's the exact opposite. So if we're told that the period is 120 degrees, keeping in mind that this is a cosine curve and the regular period is 360 degrees, you might be able to figure out what the stretch factor is by simple reasoning power, and that's good. But the other method that's 100% reliable is to fall back on the basic idea that the period, I'll use the symbol p, for a cosine or a sine curve is always 360 degrees divided by the b value. For a tan curve, it's 180 divided by b. So tan graphs have a different period to start with. Now if you manipulated this equation into the b value being isolated, you would get b is equal to 360 degrees divided by p for period. So it doesn't really matter which variable you're isolating, it's always going to be 360 divided by either p or b. So therefore b is equal to 360 degrees divided by the period of 120, and that would give us the b is equal to 3. And you weren't asked this, but if you wanted to, you could say that, well, this is a horizontal stretch by a factor of 1/3 about the y-axis. And that's what I mean as far as reasoning your way through it. If the period is 1/3 what it's supposed to be, it means that there has been a horizontal stretch factor by 1/3. So try not to make these ones more complicated than they really are. But the key, when they do get difficult, is to remember that formula, that relationship between the period and the b value. Let's look at another one. Here we have the period equal to 7 pi over 3. This is a little bit more difficult. But we recall again that even in the manipulated form, the b is equal to 2 pi over the period. So I'll go directly to this form. Don't think too hard. Plug in the period. So b is equal to 2 pi divided by 7 pi over 3. Deal with your complex fraction by recalling that this expression is really 2 pi divided by 7 pi over 3. And when you're dividing by a fraction, of course, you multiply by the reciprocal, 3 over 7 pi. And the pi's will cancel, and the b would therefore be equal to 2 times 3 is 6 over 7. So in this case, although we weren't asked, we could indicate that this is a horizontal stretch by the reciprocal of this factor, by 7 over 6 about the y-axis. So if you interpreted it according to what we did in Unit 1, that would be another way to express the answer. Typically in trig, though, we stick with things like period and b value. Let's take a look at another one. This one's different because it's given to you in a decimal form, 5.5 rads to the nearest tenth. Now, as we've seen, normally with radian measure, we deal with exact values, 7 pi over 3, because that pi is an irrational number. So in order to keep it exact, you have to have the pi intact in the equation. Here it's been multiplied in, it's been decimalized, 5.5 rads. I still would encourage you not to think too hard about it. Rather, go to the formula. B, if we're in rads, is equal to 2 pi divided by the period. So B is equal to 2 pi divided by the period of 5.5. And I'm just going to run this right through my calculator. 2 pi divided by 5.5. So this goes in 2 pi, and you should get 1.14. Now, taking this to the nearest tenth would then be 1.1. So now let's go on to these ones where we're finding equations for each of the following graphs. So we're given the graphs. We'll have 4 of them, and we are going to work out the equations. Now these will involve vertical and horizontal stretches. So this first one, we have this sinusoidal wave, and we have to identify whether it's going to be a sine function or a cosine function by inspection. Now, in fact, ultimately it could be either, and ultimately we'll have to make the decision on which we want. But for now, we can choose the easiest. And because of the orientation of this one, it makes sense to call this a sine function. So a form y is equal to a sine b theta. And we just need to go after the a and the b parameters. Now it is a sine curve because normally the starting point for a sine curve should be halfway from the bottom to the top, and that's exactly where we're oriented. So the amplitude, we could take this by inspection of the function. Amplitude should be normally the easiest parameter to find for any of these. Just the distance from the midpoint up to the top. So a is equal to 3. So that's also the vertical stretch factor. But now we have to go after b. And to go after b, we identify one period. So unlike the previous ones where we didn't have to take it off the graph like this, you were given the period. Here you have to find the period. It can be a bit of a trick. Now remember that sinusoidal curves, sine and cosine functions, break into 4 quarters. Now that's not that important for this particular graph, but in the next few ones it will be. So you may be able, in this case, to identify the period by inspection. So how far is it from the starting point to the next starting point? So 1 full cycle. So 4 pi we can identify. And then to get the b value, we use that formula, 2 pi over the period. So in this case, b will be equal to 2 pi divided by 4 pi. And then simplify that fraction, and we should just get the pi's will divide out. We'll get b is equal to 1/2. So when we write out our answer, we'll get y is equal to 3 sine 1/2 theta. So it's a horizontal stretch by a factor of 2, if you thought of it in those terms. Type of thing you can do. Now the next one will raise the bar a little bit more. So you take a look at the grid that you're given, and you have to decide cosine or sine. And because of the location that we're starting on the y-axis, the crest is located on the y-axis, makes sense to me to call this one a cosine function in its simplest form. So it'll be a form y is equal to a cosine b theta. Now the a shouldn't be a huge challenge for us. The amplitude would be from the center all the way to the top, the midpoint at the top. So by inspection, you should identify the amplitude, or a, or the vertical stretch factor is just equal to 6. And then go after the more challenging part, which is b. And as before, we need to identify the length of one full horizontal cycle, the period, in other words. Now, the grid's a little tight to see here, but I can see, on mine anyways, that the period is going to be pi over 2. Don't stop there, though. We want the equation, so we need to get the b value, and the b value will be found by the same operation we had before. We just divide 2 pi divided by pi over 2. Be careful because this is a complex fraction. So 2 pi divided by pi over 2, we need to divide out 2 pi by pi over 2. So dividing by pi over 2 would be like multiplying by 2 over pi, multiplied by the reciprocal. And again, which is what typically happens, we cancel out the pi's and we just get b is 4. So that gives us enough information then to come up with the equation. So y is equal to a is 6 cosine 4 theta. So a horizontal stretch factor by a factor of 1, stretch factor by factor of 1/4, if you like. So this one has been squeezed together quite a bit horizontally. Not that simple of a question. There's a few things going on there, so you really have to concentrate on getting good at those. This one will go a little bit further still. Decide, is it a sine curve or a cosine curve? So what I'm going to do first off, because this one appears to be neither, I mean the orientation is a little bit wrong because we're going down through the origin instead of going up. So I think that this is a sine curve all right, but what I've drawn in there is the way a sine curve should look. So in fact, this is a reflected sine function. And it's a reflection, well, I'm going to think of it as a reflection in the x-axis or the theta axis. Some of you would say, well, you could call it a different reflection as well over the y-axis, but that's another story, and you are correct. So I'm going to note that the a value is going to be -1. There's no actual stretch factor, but the reflection in the x-axis. This one, sine curves actually have this property where you could go either x or y, but that we delve into that later on. Anyways, now the period, we go from that starting point to the next starting point, and we identify the period. Now we got a bit of a problem here because the scale is incomplete. So we have to take what is given to us. And all we really have is that one measure. And that one measure is pi over 3, but that is not the full period. That's half the period. So we have to multiply that pi over 3 by 2 to get 2 pi over 3. And this will give us the full period. Very common where you're given just a section, a quarter, a half, or even 3/4. So our b value would be 2 pi divided by pi over 3. We've been here before. We now just have to divide out by that complex fraction. So b would be 2 pi times 3 over 2 pi. It cleans up really nicely. The 2 pi's will divide out. So b is equal to 3. So a horizontal stretch factor of 1/3. So this one has again been compressed, if you like, horizontally. So we'll write out our final answer. So negative, don't forget that negative sine 3 theta. It's easy to make mistakes with those, so you got to really be careful. Let's do one more, and this one will have a number of things thrown at us. So you see what's going on here. This again is a reflected graph. So I'm drawing in what a cosine function should look like before you reflect it. So we would expect the y-axis, it to be up on the crest to be on the y-axis, but in fact we have the trough, or the bottom of the curve, on the y-axis. So this is a reflected cosine function. But I will still think of it in terms y is equal to a cosine b theta. But I'm going to be aware that the a value with the reflection and the vertical stretch factor will be -2. And then I'm going to go after the period. And I've got a problem right away. Now you might have a hard time reading that, but we just have one figure. That's pi. So I've got that drawn in there. And you've got to decide, well, how much of the curve is that pi? Because here's the full period from trough to trough. And we were not given the full period. We were given a fraction of the period. So I'm going to take this, and I'm going to break it into quarters like we always do with sine and cosine curves. Now you might be able to tell this by inspection. But in fact, that pi represents 3/4 of the period, not the full period. So some of you will go directly to the full period from that. But what I'm going to do is I'm going to be conservative with it, and I'm going to find out the measure of 1/4. So I take pi divided by 3, because that is equal to 3 sections. Oops, I meant pi divided by 3. Let me change this for you. There we go. So each period, each quarter, not period, is pi over 3. And now I go after the full period. And that's not such a big deal. Take that pi over 3 multiplied by 4. And you'll get 4 pi over 3. Now you could have done that directly. You could have taken that pi and multiplied or divided by 3/4, which would then give you multiplying by 4/3. But I broke it down like that. Played it really safe. Now I carefully again go after the b value. So 2 pi divided by 4 pi over 3, multiply by the reciprocal times 3 over 4 pi. And then b reduce that fraction nicely. It's going to be 3 over 2. And we've got it. So our equation, therefore, will be, don't forget the negative, -2 cosine 3 over 2 theta. Now, this is not considered that easy of a question. There's lots going on, so you really got to be careful with it. And if you can do these well, the only thing that comes at us now is going to be the translations. So let's just review that, what we've got going in this last section there. Now the difficulty is, so I'm just taking it back to the previous screen here, is getting that period right. So that pi represents three of those sections. It's 3/4 of the period, and that's where people make mistakes. Thank you.